गुड मॉर्निंग सर। गुड मॉर्निंग सर।
गुड मॉर्निंग, कैसे हैं आप?
जी मैं अच्छी हूँ, आप कैसे हैं?
मैं ठीक हूँ।
हाँ सर, स्टिल
स्पीकर साहब आ
थ्री।
गए?
जी सर।
स्पीकर आ गए?
हाँ जी हाँ जी।
आपकी आवाज क्यों नहीं आ रही है? ऑडिबल?
स्टिल 3 मिनट्स आर लेफ्ट, तो अभी हम लोग
ऑडिबल
वेट
सर,
कर रहे
ऑडिबल।
हैं।
ओके ओके।
यस सर, यू आर।
नॉट एबल टू हियर।
हेलो, एम आई ऑडिबल?
Yes, ma'am.
Yes, ma'am.
ओके, थैंक यू थैंक यू। Hello, good morning everyone. Before I formally start the program, there are two important announcements for attendees. The one is that the attendance link will be sent in chat box after the presentation is over. And secondly, all the queries will be posted by you in the chat box. We'll collect them and send them to speaker hand to hand, and then he will answer the queries. Thank you.
काम कहाँ जाएगा हम भी करते हैं काम
तो आप रजा आवाज ना
Vikas Shukla,
तो है यार।
mute yourself. Sorry, mute yourself.
मैम कर दिया मैंने
आप
म्यूट।
लोग आपस में बातें नहीं करें, म्यूट सेल्फ। हाँ, इनको म्यूट कर दीजिए। एंड डायरेक्टर सर, शैल आई स्टार्ट द प्रोग्राम नाउ?
प्लीज स्टार्ट।
Okay, thank you, sir. Honorable Vice Chancellor and Pro Vice Chancellor in absentia, Dean Students Welfare, Dean Faculty of Science, Dean Faculty of Engineering and Technology, Director SCRIT, expert speaker, and dear audience. With immense pleasure, I wish a very warm good morning. Sorry. I, Savita Mittal, feel immensely honored to be here today and also with the privilege of extending my warm welcome on behalf of SCRIT on the occasion of webinar on 5G technology. And I request Manu sir once again to kindly mute all the audience.
Okay, ma'am.
Ladies and gentlemen, the question arises, what is 5G and what its significance is in our life? In short, it's the beginning of the fourth industrial revolution. However, to answer the questions, 5G will be the fifth generation of state of the art wireless technology, bringing a whole host of improvements to wireless networking performance. Yes, we are speaking of faster downloads, low latency, phenomenal network reliability, and a revolutionary impact on our lives, work, and play. So, to be precise, 5G speed can be as fast as 10 gigabits, and that, ladies and gentlemen, is a 20-fold. I repeat, it's a 20-fold increase over previous limitations. Intrigued yet? No. So let's hear out our expert, Engineer Mridul Jain, to unravel how 5G is poised to take big strides over the coming years and how this technology will likely impact other sectors and adjacent technologies. परंतु उससे पहले हम भारतीय किसी भी अकादमिक कार्यक्रम की सफलता हेतु माँ सरस्वती का आवाहन करते हैं। माँ सरस्वती, जिन्हें विद्या और कला की देवी माना जाता है, भारत में संगीतकारों से लेकर वैज्ञानिकों तक हर कोई ज्ञान प्राप्ति और मार्गदर्शन के लिए माँ सरस्वती से पूजा अर्चना करता है। आइए हम सब मिलकर माँ सरस्वती के शुभाशीष हेतु आराधन वंदन करें। Like Saraswati Vanna, it's our ancient tradition also to welcome our Atithi, that is the guest. Following this tradition, may I invite Professor Neeraj Singhal sir, Director SCRIT, for welcome address, please. Over to Professor Neeraj Singhal sir.
Thank you, Savita ma'am.
कोई वैसे कर लो ना, ऐसे तो वो करेगी आपस में। अच्छा आपने
Mr. Manav, kindly mute all others.
Okay, sir. Okay.
Thank you, Ms. Savita Mittal ji. Honorable Vice Chancellor, Professor Sangeeta Shukla ma'am, the Pro Vice Chancellor, Professor Y. Vimla ma'am, Dean, Faculty of Science, Professor Madhur Kumar Gupta ji, Chief Proctor, Professor Virpal ji, DSW Dean Engineering Professor Hare Krishna ji, Speaker of the Day Engineer Madhur Jain ji, Organizing Team Ms. Savita Mittal ji, Dr. Mano Bansal, Engineer Priyank Sirohi, Engineer Arpit Chhabda, Sandeep Agrawal ji, and most importantly, the teachers and my dear students who are attending this event. I, Dr. Neeraj Singhal, welcome you all on behalf of myself and on behalf of Sachotaram Institute of Engineering Technology. When I was told the institution is organizing a webinar on 5G, I was recalling the two things, especially the days when people used to use pigeons for communication and for sending messages. And secondly, the days like 20 or 30 years back, when we used to pay money even for incoming calls, not even for outgoing calls. Starting from 1G in 1979, we had seen 4G, which was referred as magic, which allowed us M for mobile multimedia, A for anytime, anywhere, G for global mobility support, I for integrated wireless solution, and C for customized personal services. And I believe that with introduction of 5G in India, we will be able to have much faster speed as compared to 4G. It will be a game changer, revolutionizing how we live and work in all industries, not just one. It will change almost every aspect of our lives, how we drive to work in the morning, grow our food, and even root for our favorite sports teams. It will completely change our lives, and we don't even know the possibilities, what will be even till date. It is very similar to 1G, which changed our lives a long back. I wish this session will be fruitful to all the attendees, our teachers as well as students. I welcome you all in this session. Thank you all. Please proceed, ma'am. Ms. Savita Mittal ji,
Sir,
proceed now. Yes, please.
not only so providing, yes, sir, but also providing the history of technology. We feel elated to welcome engineer time to present his brief profile in front of you. Engineer Mridul Jain is currently working as domain sales manager and technical solution architect in Ericsson, USA. His key responsibilities: business development manager, helping manage 180 million US dollar account for Ericsson in west region of USA, including California, Washington, Arizona, Colorado, and Nevada. Work and experience and qualification wise, he possesses 19 plus years progressive, successful IT telecommunications experience in services, solutions, business development, project management, upselling, and leadership. He's a BTech in Information Technology and Masters in Data Science. Volte IMS, Self-Organized Network, 4G LTE, HSPA, Data Analytic, Subject Matter Expertise, Product and Tools Development and Management. PMP Hash, Leadership for Professionals Certified, EPC Solution, Architect Assessed, LTE Solution, Architect Assessed. Bug Certified Senior Solutions Architect, Data Analytics, Automation, Radio Network Design, Tuning and Optimization, which includes radio networks, WCDMA, HSPA, LTE. Ladies and gentlemen, the list of achievements and award is also too long. Sir is the winner of Ericsson's Pride Award in the category of Customer Satisfaction. He also received recognition Vice President of Ericsson Radio Access Network and recognized by Customer Delivery Director for above and beyond category. Recognized by Customer Radio Access Network AVP for Los Angeles market to create innovative solutions and leadership. For best network and less networks in the nation and recognized by account team delivery director for automation and innovation by helping improve cycle time from 20 days to 10 days. Recognition by Ericsson delivery director for new business identifications, innovative ideas and helping save millions US dollars. He got Most Valuable Player Award from AT&T, EVP and GMCU for Perform Team category for 2013 contribution to accounts team. He was also recognized by Ericsson EVP and GMCU in category Innovate Every Day in 2012 for contributions to account team. He was recognized by Ericsson CU National Programs Manager for contribution to innovative ways of working, core network initiatives, and teamwork. He had been lead architect and innovator for many software tools and methods. He has worked in various countries and vendors across Middle East, South Asia, South America, Africa, and North America. With these words, I would like to invite Engineer Mridul Jain for his presentation. Sir, we are looking forward to hear your knowledgeable views. Over to Engineer Mridul Jain. Sir, please.
Thank you, Savita ma'am. Thank you so much for inviting me and giving me an opportunity to present in front of such a large audience. I just want to first, before I start, I just want to get your thumbs up if you can hear me. There is a reactions. Yeah, okay. Some of the people are raising their thumbs, so I hope people can hear me. All right. I assume that my voice is okay. Looks like many people are saying thumbs up. Good.
Yes, yes, clear.
All right. First of all, I want to thank Professor Neeraj Singhal, Arpit, who is organizing this. Thank you so much, Arpit. We had a good session yesterday just to prepare for this one. Also to Sir Choturam, Engineering and Technology Director, sir. I mean, and the organizers of this webinar. It's a really good, I would say like it's a very, very good initiative by the team. The reason I wanted to present is also because in India is growing in that direction now. We have a lot of development, a lot of innovation happening in India. A lot of cities getting connected, and with LTE, and after that now 5G, which is like LTE used to be called 4G, and now getting into 5G. The things will change quite a lot, and it will change dramatically. Now, the reason I want to say that it is very big opportunity for all of you as well. There is not just one single area where you can contribute and make your life, but also you can have multiple different scenarios and multiple different paths that you can take within the same domain, which is 5G. 5G is just a enabler, right? You basically enable a lot of other things with 5G because of the connectivity. And with pandemic and all, I think you are all of you have already seen that with pandemic, connectivity becomes the most important thing. You can work from your village, or you can go into the holiday vacation, but still work and get connected to your family, to your office, and to your friends. And the distance is just not that relevant anymore. Of course, physical and personal touch is different, but again, if you are not able to meet, you can still meet like we are meeting, right? I'm sitting like tens of thousands of miles from you guys, but I can still connect, I can still talk, I can still explain, and I am connected to 5G right now. So in US, we have started this already. We are deploying this network for all the customers. So I'll just give you a brief background, first of all, about myself. Thank you, Savita ma'am, for giving my introduction. But I started as a, I am from Meerut, right? So I started as an engineer. From here, I used to go in train to Saibabad, one of the companies. It was a very humble start, and I started doing hard work, and then I started going into the telecom domain. I used to be a software engineer. At that time, there was a telecom bust in 2001 2002, if you remember, internet bust that happened. And then after that, I get into telecom. I started working in telecom, and then slowly I went out of India, and I traveled the world, learned a lot of things, and telecom helped me. I started from 2G, which I think Professor Neeraj Singhal also mentioned, right? Where we used to have those big phones, and I will show you one of that in the in my presentation. So if you see my presentation, let me know if you guys can see my screen.
Yes, it is visible. Yes.
All right, perfect. So if you look at this, right, so I started as a 2G engineer, where we used to bring, a lot of equipment with us. We used to hang antennas. We still do the same thing, right? The telecom is still the same, but there was a big phone at that time. So how it changed. So I'll show you I'll start with a video first. So you can see, how things change. Let me know if it is visible. One second, I think the volume is not coming. All right.
They've all revolutionized the way we live our lives. And Ericsson has been leading the way. So when it comes to 5G, it's easy to think it's just about G. Well, it's not. With 5G,
Sir, the audio is not there. Video is there, but audio is not there. We cannot hear any sound.
Oh, is it? Okay.
Please restart it again.
Let me know if. So it's not coming out. Okay. So it's okay. I'll go further and we can talk about it, right? Basically, what it is, this video is trying to say is that, can you hear me?
We can hear you.
Okay,
We can
that's fine.
hear you.
So video is just, basically it's trying to say is that there will be a lot of connectivity and lot of, things that will be connected. As you can see, they are showing devices, handsets. You are in the train, you can capture videos, you can have music, you can directly streamcast it. You can directly have, these days a lot of discussion about metaverse and virtual reality, augmented reality. That will become actually reality, right? For example, I'll give you an example. You can go to a store and without in fact going to the store, you can be sitting in your house and you can go and browse in one of the shopping centers, for example, and you can be present there with your friend virtually. That's how things are going to change, right? And I will show you at the end, there is a video that will go into the details of it, how things are happening. Then there are other things, right? Machines, for example, currently, a lot of factories are connected through the machines are not connected or connected through Wi-Fi and unreliable sources, or you have to connect a LAN cable, Cat5 or something to the devices. But with 5G you do not have to have any connect. Your machine can be moving in the factory, it can be a robot, and you can still have connectivity and you can give instructions to that robot sitting in your home, and the robot will still do the work. It will be connected through the Wi-Fi or through the 5G network, and it will be reliable. So you can also look at the cars, right? Connected cars. So the cars will talk to each other. The car in front of you will be able to talk to car at the back. But all these are possibilities, right? Maybe some of these will not happen, but some of this will happen, already happening. Like, for example, you can see here, right? There is a ship and there is a lot of containers, right? This is supply chain. That all these containers will be connected, and you will know where is your box, where is your container, and that container, when it is going into the ship, you will get direct messages to your phone, and it will be very highly connectivity again. This is another mining area. Your mines are connected, and you can operate your robots and machines which can go into the mines or quarries and then transfer you can still monitor it. You can see where it is going, how it is doing things and things like that. Then there are many other things, right? Vehicles will be connected. You can have a screen in front of you. You can detect accidents, things like that. Your drones can be flying around and they will be delivering medical supplies or food, anything, and that will be also connected and very well controlled through the network. And then there are many things that will happen. So that is the overall 5G. Now I'll go through basically about Ericsson, right? With the company that I work with, I'm working for Ericsson almost now on and off. I would say like 13-14 years in total. I worked for Nokia as well as Huawei, that is one of the Chinese companies. But I think I've been with Ericsson for the longest, and it's one of the fantastic companies. It's 140 years old. People don't realize how old Ericsson is, and Ericsson is at the helm of all the innovation and telecommunications. Without Ericsson, there is no communication. There is no telecommunications. Ericsson, in general, has almost every every 2/3 of the calls, meaning 60 to 70% of the calls span and go through Ericsson network. So you can imagine, how far-reaching this company has, or how big this company is. It used to be copper wire in the past when Professor Neeraj mentioned 1G, and now you can talk about artificial intelligence and 5G. Fastest scaling technology ever. This is going to be fastest scaling technology. And then fourth industrial revolution is also starting with this, basically. So just in terms of global presence, Ericsson has almost 100,000 employees all over the world. In North America, there are around 10,000 employees working. South America and Europe, close to about 44,000. Then there is an African division, East Africa and Middle East. There is 4,000, and Southeast Asia, there are 23,000 employees. And we have 23,000 employees dedicated just for R&D. And this is just a initial, way how things have changed. First generation, we used to have analog speech. I know a lot of you are from technical background, so you might understand what is analog. And then this was called 1G. It used to called AMPS system. Very primitive, old. This is where 1979, 1980. Then it started all. Then second generation. Digital speed, when we said 2G, this is when I started working in this direction. And then GSM, we called it, GPRS. You can see here the abbreviations. And then third generation, which is 3G, which came with a very big bang. And Reliance, I think, if you remember, in India, Reliance came with 3G, and they took over the
No, 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 बिल्कुल ठीक कह रहे हो। मेरी तो नहीं जा रही हूँ आवाज।
to Reliance, and it became a very big movement throughout the world. Actually, Reliance telecom. And then fourth generation 4G, which is LTE, we call, right? And then fifth generation, which is now VR. And the thing is that all of this technology is developed by one party or body. It is called 3GPP, right? This is third generation partnership program. Basically, what it does is this is the body which defines all the protocols, all the standards, and everything for telecommunications. And this is the body which governs the development of 3G, 4G, 5G, and now going into the 6G as well. It's still work in progress. It will start into development once the release 17 or 18 will come out. So what is release? Basically, release 99 is in 1999. 3G release 99 was issued by 3GPP. Then it continued in release 4, 8, 10, 15. Now currently we are in release 16, and release 17, 18 will pave the way for 5G further. And then in 2030, people are talking about 6G. I don't know what it is going to be, but there are talks about that already, right? So this is a brief history, of 5G, how it came about, where it came from, and how things are going, and who is 3GPP. So this is the most important body which actually governs. There used to be CDMA, if people might remember, but that did not work. So now you will not find many networks with CDMA. Wi-Fi is still there, but Wi-Fi is a very niche area, only in offices, but it's unreliable, but it is improving now. But 3GPP is the only body which actually defines telecommunications, actually, right? Now, what will 5G bring, right? So basically, it is one network supporting multiple use cases and industries. And basically, what it will do is it will have 10 to 100x end user data rates, meaning the throughput that you will get from your mobile phones. 1000x data volumes, so you can watch videos, you can stream anything like songs and etc. You are already doing it, right? So this will become much more faster, very high quality, and data will become even more cheaper, but it will become more faster. 100x more devices. The cost of the devices will go down because you will be able to get a very good phone, but in lesser price. 10 plus years of battery life for the devices which will be installed in your, for example, connected devices. For example, you can have a sensor at home which can just give you one reading per day or 2 readings per day, and it can continue to do that for 10 years, right? It can be a security device or something like that. It can penetrate very deep into the building, meaning I will go through that. What does 20 dB better coverage mean in the next slides? But and then of course latency, because this will be very near real-time communication, which will be very critical for 5G to happen, because virtual reality, augmented reality, you need very low latency, otherwise it doesn't give a good experience. So you need to have a very good, very low latency, meaning within milliseconds you should be able to communicate with the other person, and you should be right there with the other person in augmented reality. You just have to have very fast reaction time and data transfer time. What industry says is that if big data is the new oil of digital era, then 5G is the next set of pipes that will deliver it. As I said, right, 5G is enabler. 5G is the enabler for the next generation of industrial revolution, of big data, of software development, or any other thing like gaming, right? Video games or something like that. So 5G is at the core of it. It's going to be the core of it. 5G in numbers right now, so you can see 180 global live networks right now. 97 of them are from Ericsson, half of them or more than half. 1060 announced 5G devices, 1000 devices already announced in 46 countries, 27 GB of data mobile consumption just in Korea. And Ericsson has 11 standalone networks for 5G, and 57% of the 5G device traffic is coming from South Korea, and 33 Ericsson networks with Ericsson spectrum sharing. I don't think we need to talk about this, but this is basically the 5G network or 4G network or 3G or 2G. It only works on certain frequency range, right? There is a frequency, and that frequency is basically called spectrum. And when you share that spectrum between technologies, it's called Ericsson Spectrum Sharing, ESS, right? And Ericsson is the innovator in that. So you can share the same spectrum between technologies, and you can still get both the technologies to work at the same time, right? I know there will be questions, so paste your questions when you have. I will answer once we get to the end of it. So the trends that are driving the growth basically are automation. There are 1.7 million new industrial robots, as I said, will be installed by 2020, already done. Big data, 10 times growth in global data util until 2025. So now, as you can see, a lot of companies are working on big data, machine learning, etc. But how do you transfer all this data, and how do you use that data? Currently, you can use Wi-Fi, but if you are outside, if you are in a place where you need to communicate from your phone, you need 4G, 5G type of connectivity. And if it is big data, you definitely need 5G. Then artificial intelligence, you need to continuously train your models, and you need to continuously have that kind of feed coming in. For example, there is a factory. In that factory, you have a lot of sensors. A lot of sensors are sending certain data to the servers, and all those sensors are sending that data. They have to send immediately in real time, and that data needs to be processed. And machine learning or model need to get developed and then take actions based on those sensors data. And this should happen in real time, right? It's basically that your factory is running and you are using data to manage your factory operationally very effectively, right? You do not want to send people when there is no need to send certain people. Like, you need to reduce your operational cost, etc., right? So that is one. And then AR, VR, as I mentioned, right? There was a discussion about somebody going to Home Depot, and that guy was old. So the person said that you do not have to go to Home Depot. Home Depot is a store here. So what they did is they created a virtual environment where the person actually sits at home, but he's sitting in Home Depot as an experience. So he puts glasses and he can be in the Home Depot sitting in his house, and he can browse the material or the shopping list in Home Depot sitting at his home, and he can pinpoint and select the bucket or basket or cart, you call it in the e-commerce terms, and he can add to cart, and he can just directly order, and the order will be delivered to his homes without going to the store. That is something revolutionary, right? You really need connectivity for that. And all these companies like Microsoft and others are working on HoloLens and hologram and all those technologies, but this will only be possible when you have very high speed connectivity and data, and that is what is 5G is going to enable it. So it will help in smart manufacturing, Internet of Things, and also computing using all devices. And this market is growing at 20 to 25% per year, right? So this is a very good growth area as well, right, for the future. So when I said in the beginning, if you remember, I was saying that you can take or contribute or take your own path. There are multiple paths that you can take, and 5G could be an enabler for you. Automation is one, big data is another, AI machine learning is another, and virtual reality is another, right? So there is a there are few phases of 5G RAN evolution, right? Basically, what you have to do is, if you see, this is the foundation that you need to have flexibility in deployment. you should have a spectrum and energy efficiency, because you cannot burn too much energy just to make sure that you are deploying and transferring the data. You have to transfer the data with even lesser electricity to be consumed. Capacity has to be very high. Coverage, you need to penetrate the building, you need to cover remote areas, etc. And you should do it with a very good user experience, otherwise users will not use it. And the operational efficiency means that when you deploy certain element, or let's say there is a tower, I know in India a lot of towers and rooftops have antennas. So those antennas need to be operationally efficient, meaning you cannot have certain antenna or component that you can deploy, and later on when the rain comes it doesn't work. That will be operationally inefficient. So all those components should be operationally efficient, very sturdy, very robust, and of course service enablement. Then you have RAN automation, time critical communication, multi-use case optimized network, and next generation of multiband and wideband and RAN integration. That is the exploration phase. And then extreme performance, limitless connectivity, and cognitive network, that is next. Once you have explored, and then you need to do more research to make it more better, and get better juice out of the deployed assets that you have deployed, right? And now when I say deployed, means that every 5G site or 4G site or 2G site or 3G site will have certain elements. What are those elements? They will have a tower or a rooftop where you have a small pole, or a location where you have to deploy antenna. Antenna will be like a panel shaped antenna. You may have seen hundreds and thousands of in India. Those are the antennas which are actually transmitting the frequency with a certain power. That frequency is only good for that particular area, meaning the frequency, as you know, right? What is frequency, right? It all begins with frequency and wavelength, right? So if you know, and you are from some technical background, then you might know that frequency of a wave is inversely proportional to its wavelength, right? So if you have a higher wavelength, then your frequency should be low. If you have a low frequency, this means you can go far, right? Your wavelength is more, so you have a high wave, right? When you have a long wave, it can go further, meaning, for example, when I'm talking, right, my voice can be heard in the other room, right? So my wavelength of my tone or my voice is such that its frequency is such that it can be heard in the other room. But if you take the same thing, like for example a light, like I have a light here, but the light has a different wavelength. It cannot go to the other room because the walls cannot penetrate the wall, right? Same is the case with frequency. Electromagnetic signal is dependent upon wavelength. So if your wavelength is high, wavelength is big, then your frequency is low. This means even though you have low frequency, you can cover wider area, right? So you can see that here, low bands, sub 1 gigahertz, or like for 900 megahertz, etc. Radio used to be, I think, I forgot, but in India, radio used to be 102 kilohertz, and it can, one tower in Delhi can give you, the signal and song. You can hear the song until maybe Meerut, Partapur bypass or some place like that, right? And even sometimes in Meerut, if you have an antenna on your car or something, you can still hear the Delhi's radio, right? Because that frequency is very low. Oh, sorry, frequency is very low and the wavelength is very high. Same way, if you talk about this, then if you have a network where you have a low frequency, then you can cover very, very large area by that tower. Now, the problem is the low frequency means you have low capacity, because you can only transmit certain number of bits in that frequency, because it's a very low frequency. When you have low frequency, you can transmit less information. Then, so how will you communicate? So you need high frequency. That's where it comes 5G. right? So when you have mid band, which is 3.5 gigahertz to 6 gigahertz and 24 to 40 gigahertz, what happens is the frequency is very high now. And when you have very high frequency, you know, the signal can go within that frequency very, very fast. And you can send the signal or all the bits, because what is data? Data is just 0 and 1. You have to send that 0 and 1 through those frequency, that frequency that you modulate. So when I talk, I can convert my talk or or my sound into digital bits, and those digital bits are what I am sending into my laptop now, and that is going into your into the Wi-Fi network that I have in my house, that or 5G network that I have in my house, and then it goes out from the optical fibers through the sea ocean to India. It connects to, some VSNL or some other gateway. From there, it goes to your mobile phone provider switch. From that, it goes to the tower which you are connected to if you are listening through mobile. And then from that tower, the antenna is radiating that frequency and you are able to hear me. And do you see, when I say latency should not be that high, my talking and your listening does not exceed more than 120 milliseconds. That's incredible. And what 5G is going to do is basically that will reduce the span to 15 milliseconds. And that is huge, because now my volume or my video is slightly delayed. But when the 5G will be there and you also will have 5G, it will be pretty much real time, right? That's the whole point. And what enables it is frequency, right? Here you can see that high frequency, you have high capacity and ultra low latency. And that is where the 5G magic will come. And of course, high capacity, of course, the problem with high frequency is that it does not penetrate the buildings very well. So you need to deploy more. You need to deploy more sites, more antennas, etc. And it needs to be very localized deployment, meaning wherever you need really high capacity, etc. Right? So there are there are multiple bands and so things and etc. So I can just talk about these, right? They call B, whatever is B means band. Band 20 is 800 megahertz, which is low frequency, and it goes on. And you have like band 7, band 38, which is 2.6 gigahertz. And currently we are talking about C band, which is basically in US. C band is 3.4, 3.5 gigahertz. And then there is a millimeter wave, which is 28 or 39 gigahertz. So you can see here, right? As you can see, 28 to 39 gigahertz is 5G millimeter wave. This is B42, 43. This is also part of 5G. As you can see, that color is getting red. So this means it's more of a 5G type of frequency. So it doesn't matter whether you have low frequency or high frequency. 5G is still same technology. You can still use 5G in low frequency, but the use case will be different, right? In this case, the use case will be for sensors. In this case, the use case will be for high data rate transmission, right? But it's still called 5G. Currently, we are transitioning from 4G. These are all 4G bands. And slowly, when these 4G bands are going to be converted into 5G bands, later on, all of these will be used as 5G, right? As you can see here, right? So all of them become red, and NR means, so you can go back to the slide here. Oh, sorry. Yeah. So NR means nothing but new radio. They call it new radio, right? But it's called 5G radio. Now, so as I said, right, 5G is basically done by 3GPP. 3GPP is the one who develops all these standards and protocols. And ITU is another standard body which actually defines the requirements. And 3GPP basically prepares all the protocols. And new radio non-standalone and new radio standalone was developed in release 15 and release 16 within 2017 and 2018. So it's relatively very new technology. So they create all this framework and protocols. send the proposal to ITU. ITU evaluates, and then the specifications get created, and those specifications are then converted into the software, and that software is then deployed into those. The next slide will tell you how on the radios and the basebands they call it, right? So basically, what is a site? So you can see here, right? There is a tower, and on the tower there is an antenna, right? And that antenna transmits the frequency. But bottom of this tower, or at the top of this tower, there is a radio also. Radio is the core component of any data transmission. Radio is the one which is, it's not a radio that we used to hear in the past. This radio is basically radio frequency radio, which actually is a transmitter and receiver of a certain frequency, and it has some software inside it, and that radio is then connected to the baseband, which is at the bottom of the tower or inside a shelter here. Like there will be a shelter, and then this shelter will have a radio, or sorry, baseband, and then baseband is the one which actually schedules the all the transmission of this thing. Now there could be small tower, there could be a large tower, but all these towers are connected, meaning when you are moving out of your house, you are still connected. Your call does not drop because your towers are sending signal, and those signals are going from this tower to this tower, and this tower says, okay, I can handle this call, and I can handle this mobile. This mobile will be handed over to this tower, then the mobile will move in this direction, and then it will hand over to this tower signal, etc. Whichever tower has a better signal, it will continue to hand it over, and your call will never get, I mean, in general, in ideal scenarios, it doesn't get dropped, but yes, there are places where you do not have any coverage, and it drops. And then and then there is a standalone and non-standalone. This is just a 5G concept. Basically what it says is that non-standalone is your 5G and 4G core network. Basically, if you remember, I told you, right, this is a baseband, but then baseband has to be connected to the switch, and that switch needs to be connected to the gateway, and that gateway needs to be connected to the other country's gateway, and same way the network will be there, right? This particular is basically saying that your 4G and 5G core network, which is like switches, etc., are similar or same. It's just that you do not have to deploy a completely separate core network, but standalone means you have a completely new 5G core, which is brand new, and you deploy all your network onto that for 5G, right? So that is many operators are doing it now, but there will be connectivity to the old core also, but that's a separate thing, right? And you, as I said, right, how the network evolution happening? As you can see that I said the towers are there, then there is a radio unit, and then there is a baseband. Now in the 5Gs, what is happening is that you still have the towers and radios, but these basebands are now going into further location, which is called hubbing is happening. And then when the cloud RAN will come, which is what is happening currently, or virtualization, etc., then there will be a radio function, and these radios will also be interconnected, and this will go into the hub, where the baseband will be from the suppliers or providers who are basically using all the just the uh, general purpose hardware for aggregating all the data, right? So these are more technical terms. I do not want to go into detail, but I think this is good for you to understand what it is, how the network is used to be, and how network will be, and where we are going, right? Basically, this is called centralization. This is called old traditional. This is centralized. This is cloud architecture. And I just put some photos also of a real site. For example, this is a radio unit with an antenna integrated to it. So this is antenna, and below or behind it is a radio, and you can see that there are 3 radios on one pole. They are all connected to each other, and then one wire goes down, and gets connected to the baseband, and then you have other basebands, similarly other towers, etc., which are connected to it, right? And this is a photo of a real tower in US, one of the markets, and you can see that this is a 4G radio, and here you can see there is an antenna, right? So this antenna, this is antenna plus concealment. You call it concealment because you cannot show antennas in US that easily, so they have to hide them inside this concealment. And this is how this looks, right? So you can see here, this is an antenna which is one of this, and this is a 5G radio, 1 2 3, and these are 1 2 3 behind it. These are 5G radios, and this is a 4G radio, which is and the radio and the antenna which is here, and which is here antenna, and then you can see that this is a radio, this is another radio. So you have one radio here, one antenna here, and then there are 3 5G radios and antenna here. So you have 4G and 5G radio tower right here, and this is how the connection goes, right? These are all the wires and connections, etc. Of this is an actual drawing of one of the sites, right? So 5G revolution creates endless possibilities, which we know, right? Automotive, smart vehicles, energy metering, I already said. Transport, smart vehicles, they will all be connected, they will all be sending signals, so that it's more safe, secure, and also, you know, any issues for the long route buses, etc., or trucks, transportation industry, it gets a lot of boost with that. Mining, as I said, healthcare. Right now, I think in US a lot of hospitals are getting 5G, because they want to have all their machines now, instead of all the wires they have. You must have, I mean, some of you may have gone to the hospitals where you can see, you know, the machines in the hospital are connected through wires, a lot of wires, and they have to be connected, and then the data is getting transmitted to the doctors or the nurses laptop or monitoring screen, and that all that can be, wireless. Basically, it can be wireless. So a lot of hospitals are adopting that now, and then you can take those devices to other rooms easily, right? With the lot of wires and Wi-Fi cables, etc., or LAN cables, it's very difficult, but it's possible in future. And then manufacturing also, as I said, right, in a lot of lines and manufacturing industry basically can use this as well. So I know I don't know how much time we have, but I have a very good video which I wanted to share with you guys today, so that you get a good feeling of 5G and how the 5G is and what is happening. So what I did is I created one, or not created, but I found one video from Japan, the one of the very advanced countries in 5G, and so I will play
Sir,
that
you can
video for
play.
you. Yeah. So once I play, let me know if you can hear this volume, because the volume is having trouble. Mhm. Can you still hear it? Can you hear it?
Yes, sir.
Yes, you can hear, right? Were you able
Yeah.
to hear the video?
No.
We can see
No.
the
Okay.
video.
Yeah, that's the problem. So
Uh, Sir, can you please explain these clippings and these pics on your own? Because we cannot hear anything.
yeah, I can paste this link, and maybe if one of you, maybe Arpit, if you can maybe play this, that would be good, if that is possible. Hello, can you hear me?
Yes, sir.
Yes, sir.
Yeah. I'm saying that I can paste the but how do I paste it? So Zoom link is gone also. Oh, there it is. Okay. if you can play this and let's see if that works. I will stop sharing. You can start sharing if you want. So it's a little bit longer video. I just wanted to have a longer video for a little bit more, clarity on how it will happen. So I'll just give you a brief update on this video. What it says is, it's basically talking about one person who is going to his family to meet in Japan, and it's a story about him, right? And how 5G is enabling him or helping him every step of the way, and what are the things that he will encounter and how amazing it is, right? Okay, we can play. Thank you.
Sir, it's not audible.
Okay, can you hear me now?
Sir, your voice is not clear.
Sir, you are not audible, sir.
Can you hear me now? Can you hear me now? No, not yet.
No, sir.
अजीब सी आवाज आ रही है, थोड़ी थोड़ी आवाज आ रही सर।
Hello, can you hear me? Okay. I hope you can hear me now. Hello. Can you hear me now?
Yes sir.
Okay, perfect. Yeah, that's why. All right. So there are technological challenges also, right? That's how we need to solve, right? These are the challenges that will get solved once we have all these sorted out. So what do you think? Where do you want to be with 5G? So you can see that in that video, the person he goes into the train, wants to change the song, whatever he wants, he changes it without touching anything. It's just in his, on
Sir,
his.
voice तो clear नहीं हो रही.
Yeah, I know, but
Sir, voice is
okay.
not clear.
Can you hear now? Not yet. Okay. I hope you are able to hear. I will talk slowly, right? Maybe there is a delay or latency, as I said. Because of that, the voice is not coming correct. That's fine. So you can see that person sitting in the train going to his, grandmom and granddad in a village. He goes into the place, buys things. There is nobody sitting on that shop, but his card gets, you know, uh, basically money gets collected from his card, right? He talks to a foreigner in different language, and he was able to communicate because the language translation is working, and he doesn't have to store anything in his phone for translator. It's just automatic. You just switch on the phone and switch on that whatever language you want, and it will translate and it will tell you, and you will understand. There is a drone that was flying for a granddad, and he was able to monitor his drone because he was you know trying to fertilize his fields using that drone, and he was able to control it through his phone. Then when he reaches to his granddad and grandmother, they were able to have celebration with them. And he was not able to bring his wife and other friends or brothers and sisters, but they were able to be there virtually, real time, and they were almost there. So I think that is what in reality it's going to be, maybe from now, maybe 10 years from now. But this is the direction that people who have developed this technology, people who are working on this technology, people who have invested in this technology have envisioned this is where they want to be, this is where they want this world to go, and this is how the world will look like, or it should look like. It's cheaper because you do not have to spend too much time traveling, etc. And it's also feasible because everybody has limited amount of time and everybody is busy. This will create less barriers, and also it will help bridge the distance that, for example, I have with my family back in India. it will reduce further. I think with that, I will rest the 5G case. And I would say that good luck for you all. I know it was difficult due to technology challenges and all. Me sitting in US, you are, in India, a lot of you are remote. In fact, pretty much all of us are remote, but we are still able to be connected. And I hope you got something out of it. There are many resources and books and things that you can read about it, and it's up to you what you want to do. But this is something that will help you or enable you. When you have 5G, it's possible. Thank you.
Very good, sir.
Yeah, I have some questions. Savita ma'am or Arpit, I have some questions. I will be able to answer few of them. But
Okay.
yeah. So the one question is, how will 5G latency be lower if
We
processing?
welcome
Yeah.
Professor. From chat box. Okay. Once I cannot see the chat box. नहीं वो तो है तो सही, लेकिन एक मिनट वेट. Shashank wants to know, will Jaybird when 5G is deployed?
Yes, so I was answering this, right? So yes, fiber deployment will actually increase. The reason is you will have to connect the towers or the poles with very high speed backend connectivity, which will be fiber or microwave. Now, microwave, it is there, but it's high frequency and short haul or short range. So you will definitely need a lot of fiber cables going into the pole or going into the tower. That will take the signal back from your tower or antennas to the switch. So fiber definitely will increase. Now, let me give you an example. In AT&T in US right now, they are deploying so much fiber strand that you can span the earth three times. That is how much fiber they are deploying. Same is the case with other operators, because every fiber that you deploy, you will have multiple strands in it. So that's why if you add that up, every strand of it, that's why I'm saying, right, you can wrap earth three times with that fiber. So the fiber will increase. I think the other question is, how will 5G latency be lower if processing is being done in the cloud? So basically, if you think about it, right, even today, a lot of processing is done in, either in the internet gateway or, in the servers, etc. So this is not going to change much. But the thing that will change is that currently what you do is you send your signal at a very low frequency or lower frequency channels to the gateways. That adds additional delay. So that will become faster because now you are using high frequency signal to send the same information very fast. So your decision making will become very fast, right? Meaning your signal will transmit quickly. Your information will transmit quickly over the air I'm talking about, right? So that's why it will reduce your overall latency. And it is happening already. We see millisecond right now in the networks that we have deployed. Yes, that is also correct, right? Before a few days back, yeah, FAA, which is Federal Aviation of America, basically, they have said that I don't want to go into the details of it, but there are talks about it. They have allowed some sites now to be deployed. There is a some of the planes they have or radars they have, they may have some interference with those same frequency bands, and that's what they are highlighting as a problem. So that's why they said that they do not want to have this 5G, because the planes will be interfered by that frequency. So what operators did here is they do not want to shoot the signal or antenna in the same direction where the plane is landing. So or the site which is near the airport, they do not want to deploy that site for now. But the solution is different, right? They need to upgrade their uh, systems within the aeroplane, which is very, very difficult as well, right? Because they use very old technology and bad filters for filtering out the signal. I don't know how many 5G towers are there in India, but I'm assuming there will be millions coming. I mean, when 5G will be deployed, it will be millions, right? If you really want to utilize that, it will be probably in tens of millions, right? Next question is from Sajid. Is there any chance we'll lose our database through vulnerable attacks? As 5G connects with more devices, the chances of attacks will be high. Yeah, of course. I mean, that security is at the core, right? We were talking today, we had a discussion with our CTO teams that one question came that when virtualization and cloud RAN will happen, meaning cloud radio access network, when the data will be in the cloud, what is the security breach and chances? Because there will be a lot of other components that will be connected. Right now it's kind of a black box, because one site at a time, you cannot attack one site, right? But if you have all the sites coming into one hub, there is a chance that security may be breached. But again, it is true with Amazon Web Services as well as Azure, all the other cloud providers as well. But for 5G, security is at its core. And if you look at the architecture, 5G is very, very well thought out protocol and specifications, right? So it's not easy to attack a 5G network or a 4G network, for example. Yes, you can replicate the SIM cards, you can duplicate them and things like that. That is something that people do. But as such, attacking the network is not easy. I don't know if you have heard any big network attacks for BSNL or or Airtel or anybody like that. I haven't heard anything like that. I mean, their networks may go down because of their own errors, but normally their networks stay up 99.999% of the time. Yes, 5G is secure. I mean, as far as I know, it is secure, right? I keep hearing that 5G will require millions of small cells. Why is that? So as I said, right, the reason is the frequency. You have very low frequency, as I mentioned, right? It all starts with frequency. If you have very, very high frequency signal, it will not penetrate the walls. It will not go further, because the fading of high frequency signal is very high. So it will only propagate certain distance, and after that the wavelength, because of the wavelength, it will not go that far. So if you really have to understand it, just look at the formula of frequency. Frequency is inversely proportional to wavelength. So if you have a very high frequency signal, it will not propagate further. When you do not have a signal, you will not be able to use 5G. So you have to boost that signal by putting another tower. Similarly, you have to continue doing that. Okay, the next question is, will 5G SIM work on 4G phones? No, 4G phones are only capable of 4G. So you need to have a 5G phone, but your 4G SIM can be converted to 5G SIM. But you cannot have a 4G phone and use 5G. It won't work. Does 5G have more radiation than 4G, 3G, or less radiation per human health environment? Okay, so this question is very, very often asked by many people. Think about it. Your phone is much more dangerous to you than 5G or 4G. The reason is your phone is right next to you always, and it is radiating the same frequency and pretty much more power because it is very close to your ear, for example. But your towers, for example, where your antennas are mounted, they are coming, with a certain power, but by the time they reach you, their signal strength is so low that it doesn't harm anything. At least that is what the study says. And your phone actually that you have right here,
सर इंग्लिश समझ नहीं आ रही
कोई बात नहीं, मेरे को हिंदी भी आती है, सो इट्स फाइन. बट मैं ये कह रहा हूँ कि जो 5G है उसका जो रेडिएशन है दैट इज नॉट दैट हार्मफुल. वो इतना ज्यादा हार्मफुल नहीं है ह्यूमन हेल्थ के लिए. आपके फोन का जो सिग्नल है दैट इज मोर हार्मफुल बिकॉज यू हैव द फोन. आपका फोन जो है वो यहाँ पर है एग्जैक्टली, और वो सेम सिग्नल छोड़ रहा है जो वो टावर छोड़ रही है. सो दैट्स व्हाई. हाउ विल
Sir, if we use iPhones while calling, so it is good or not?
Yeah, everybody uses iPhone right these days. It doesn't.
Sir, earphone, not iPhone.
Earphone
while calling.
Yeah,
Sir,
better. It is better, but again, yeah, it is better. Earphones are better because you are not very, very close with your phone, because your phone has a transmitter. The phone has a transmitter. It transmits the signal. And when you have a phone right here, it transmits signal. It is right here, right? In this area. But when you have a speaker or an earphone, you can put it here. Your phone is still transmitting the signal, but that signal is now very weak. By the time it reaches your earphone has an amplifier. It amplifies the noise and sends it inside you. So that amplifier is not basically additional power, I would say, and it's not going to damage. But it's very subjective. Nobody has any proof of anything like signals are causing any problem or anything like that. I'm just giving you an example that if this question comes, I believe that your towers and the antennas on the tower are less harmful than directly your phone. That's what it is, right? How will 5G change the wireline architecture that currently supports 4G mobile? No, wireline architecture does not support 4G. 4G is also supported by the same architecture that 5G will be supported on. It's just that the core network will be different. So if you look at the architecture, you will be able to understand. Yes, there will be components. Your wireline architecture will be connected to the wireless architecture through protocols. There are protocols that are defined by 3GPP to connect those core networks. But they are I mean, 5G will not change the wireline architecture. Okay, the next is, will 5G smartphones support 10 Gbps?
Sir, as we are running short of time, so what we can do, that all these questions can be collected and we can email you, and then those queries can be answered. So time and again I am getting the instructions from higher authorities to wind up the session. So before closing the session, you have said 5G revolution creates endless possibilities. A very big thank you to you, sir. Your lively and knowledgeable presentation will definitely help us to know 5G technology in much better way. Impressive history of 5G, its application areas. What will 5G bring, especially latency and global figures? Trends drive growth in fields of automation, big data, artificial intelligence, virtual reality, etc., and then frequency and wavelength. Your interesting and very vivacious Japanese video to show how the world is connected through 5G. You also presented 3GPP 5G time plan, and then the question answer session, the very knowledgeable answers and interest for interesting questions, and still few are remaining. Those will be collected and will be emailed to you. Sir, thank you so much for enriching our little treasure of knowledge. Thank you so much. We are looking forward such sessions in future also. Thank you so much. So as we are reaching closer to ending the session, may I request Engineer Priyank Sirohi to kindly convey the vote of thanks. Engineer Priyank Sirohi, over to you.
Thank you, ma'am. From bottom of my heart, I would like to thank Honorable Vice Chancellor, Pro Vice Chancellor, DSW, Dean Science, Dean Engineering and Technology, Proctor in absentia for their motivational support. I am Madam Professor Jemala for gracious presence and blessing. I am also highly thankful to Professor Neera Singhal sir, Director SCRIT, for all kind of support to organize the event. My sincere thanks goes to Engineer Mridul Jain, who enriched the knowledge in 5G technology with such a vivacious and lively presentation. Thanks to faculty members, Ms. Savita Mittal, Engineer Arpit Chhabra, Bansal, Dr. Pankaj Vikas Jain, Dr. Sasi, Dr. Vandarana, Ms. Rashi, Ms. Nidhi, Engineer Vidush Sharma. Technical and background support, Mr. DP Singh, Mr. Pradeep Sharma, and students, Mr. Viral and Mr. Vikas for organizing the event successfully. I am also thankful to media person who always give an appropriate coverage to our events. Last but not least, I thank all attendees for joining us. Thank you.
Thank you, sir. So, after all this presentation and this session, at the end of the session, I request all to kindly stand on your place for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Jai Hind. Thank you and have a nice day. With this, we are announcing the end of the with this we are announcing the end of this webinar. Thank you so much.
Ma'am, I have one query.
ओ मोबाइल खेलो खिलाफ चल